I'm Andy Howell. I'm an astrophysicist at Las Cumbres Observatory and a physics professor at the University of California, Santa Barbara. Normally on Science vs. Cinema, we review the science in movies. But this time, we have breaking scientific news out of my observatory. It's about the discovery of a new astrophysical phenomenon called a kilonova.
Sure, most of you have heard about gravitational wave detectors. These are the LIGO detectors in Washington State and Louisiana. About 4 kilometers long each arm. They're two identical instruments, and their purpose is to measure the passing of gravitational waves through the Earth. Gravitational waves are distortions in space-time.
On August 17th, the two LIGO detectors in the United States and the Virgo detector in Italy measured the distortions in space-time coming from a gravitational wave passing through the Earth. NASA's Fermi satellite detected gamma rays coming from the same direction in the sky. These signals were unlike anything we'd ever seen before, but they were exactly what was expected from the merger of two neutron stars, producing a catastrophic explosion called a kilonova. These are solid stars, harder than anything you can imagine, and they're like a giant atomic nucleus, only one 10 miles wide and more massive than the sun. They're composed entirely of neutrons. They're almost black holes, but not quite. The problem is, by astronomical standards, these explosions are faint and fast. As a result, astronomers had never seen one. So we get this alert from LIGO. And then what happens?
Right, so they send us this localization region in the sky, which was about 30 square degrees big, and they say, you know, the event happened somewhere in here, but we don't know exactly where, which is why we had prepared this software in advance that would figure out what galaxies in those 30 square degrees we should be looking at first, based on their mass and distance, and then sends that information to the telescopes, and the telescopes start looking at these galaxies one by one. Lucky for us, galaxy number 5 on our list was the one that had the explosion in it. There were like 5 other groups that were looking at the same galaxy as we were in the same span of 45 minutes. And then we all started sharing our information about what we had seen happen there.
Even satellites in space got in on the action, like NASA's Swift satellite and the Hubble Space Telescope. Ground-based telescopes were at a disadvantage though. The explosion was only visible for about an hour at the start of the night. You'd then have to wait 23 hours to see it again from the same telescope. Getting around that limitation is exactly why we built Las Cumbres Observatory. It's a robotic network of telescopes placed all around the globe so that there are always telescopes in the dark. These icons represent where we have telescopes. When we first discovered the explosion, it was over Chile. But then, as the Earth rotated, we picked it up again over Australia. And then, 8 hours later, we saw it over South Africa. In the 24 hours that the Earth takes to rotate, we can observe the explosion 3 times with our network.
So this is the initial light curve. It has some of the data. There's still some more we can extract. Do you want to see it?
Yes, let's see.
Like that is one day.
Over the next few days, we saw the explosion fading really quickly. It's the kind of observations you can only make if you have a global network of telescopes.
So do you have the latest spectrum?
Yep. I've never seen anything like this before.
Yeah, that is weird.
You know, you can then usually read off what elements are in there. I mean, we're all pros at this for supernova. We just look at the spectrum and say, oh, look, there's calcium, there's silicon, there's whatever. But this damn thing, you don't know what the velocities are, and we don't know what the elements are because it makes weird elements. And it's full of damn neutrons or something. I mean, what the hell does that look like when you make fusion inside of a ball of neutrons? Astronomers have long theorized that 2 neutron stars smashing together would synthesize heavy elements like gold. In fact, your jewelry was probably made in an explosion just like this, in some kind of cosmic alchemy. Using this data, we can probe extreme conditions not possible on Earth. We can test Einstein's theory of relativity in new ways, and we can finally solve the riddle of how the heaviest elements are made. It's hard to explain to people how this is such a different kind of discovery than we've ever made before.
Right, because until now, almost everything we know about the universe we've known through light. For the last 500 years since the telescope was invented, that was our only way to study the universe. So it was like we were only seeing the universe, but we couldn't actually feel or hear it until these gravitational wave detectors turned on. And now, for the first time, we have both gravitational waves and the light from the same event at the same time. And that is really not just a new discovery, but it's a new way of making discoveries about the universe.
We felt the universe shaking from two neutron stars merging together. And then we had smart, fast telescopes that allowed us to watch the explosion while it was still going on. And it's only possible because we have new technology. Anytime you can see the universe in a new way, you're gonna make new discoveries. This one really blew our minds.